You've looked at it thousands of times, drawn it as a child, wished upon it, sang songs about it. But here's what nobody told you: you've only ever seen half of it. The moon has been showing you the same face your entire life, the same craters, the same shadows, while hiding its true nature on the side you cannot see. And when China finally looked behind that mask in 2024, they found something that rewrites 4 billion years of history. The moon isn't dead. It isn't simple. It's two entirely different worlds pretending to be one. And the side we know, that's the lie. Now, I know what you're thinking. The moon? Really? We've been there. We've walked on it. We brought back rocks in the 1,970 seconds and declared victory. We moved on. But that's precisely the problem, isn't it? We moved on. We stopped asking questions. We stopped being curious. And in that gap, that 50-year silence between exploration and assumption, the moon kept its secrets. Not maliciously, not deliberately, but simply because we never thought to look at the other side. You see, the moon does something rather extraordinary. It's what scientists call tidally locked. It spins at exactly the same rate it orbits Earth, which means it always shows us the same face. Always. Every night of your life, every night of your parents' lives, every night of human history, we've seen the same craters, the same dark patches we romantically named seas. Maria, the Latin word for seas, even though they're nothing of the sort. They're oceans of frozen lava, volcanic eruptions that happened billions of years ago and left permanent scars. But I'm getting ahead of myself. The point is this: familiarity breeds a very particular kind of blindness. When we see something every day, when we think we understand it, when we've given it names and stories and meanings, we stop investigating it, we stop questioning it. And that's what happened with the moon. We assumed that because we could see one side, we understood the whole thing. We assumed symmetry. We assumed sameness. We assumed that what's true on the near side must be true on the far side. And we were catastrophically wrong. Now, why does this matter to you? Why should you care about rocks on the moon when you've got a life to live down here? Because the moon is teaching us something profound about how we see the world and how we see ourselves. It's teaching us that the things we think we know best are often the things we understand least. It's teaching us that familiarity is not the same as understanding. And it's teaching us that there's always another side to the story, even when we can't see it. For decades, and I mean this quite literally, we've been told the moon is simple, dead, inert, a companion, yes, a beautiful nightlight certainly, but essentially a lifeless rock with nothing left to tell us. Apollo astronauts confirmed it. The samples were dry, ancient, geologically inactive. The volcanoes had died 3 billion years ago. The moon was a museum, not a living world. And so we left. We planted our flags, took our photographs, and turned our attention elsewhere. Mars, the outer planets, distant stars. Why stay with something we'd already solved? But China didn't accept that story, and in June of 2024, they did something no other nation had ever attempted. They landed a robot on the far side of the moon, not the side we know, not the side we've photographed a million times, the other side, the hidden side, the side that never, ever faces Earth. And what they found is genuinely shocking. I don't use that word lightly. What they found is evidence of a completely different geological history, different chemistry, different timeline, different fate. The far side of the moon isn't a mirror image of the near side. It's not even a distant cousin. It's a fundamentally different world that happens to be glued to the side we know. The moon is two-faced in the most literal sense possible. And for 4 billion years, it's been hiding that truth in plain sight. Let me tell you what makes this so difficult, so audacious, so bloody-minded brave. Landing on the far side of the moon isn't just technically challenging. For 60 years, it was considered essentially impossible. Here's why. Radio waves travel in straight lines. They don't bend around corners. They don't wrap around spheres. If you send a robot to the far side of the moon itself blocks your signal. You can't talk to it. You can't steer it. You can't tell it to slow down or speed up or avoid that boulder. You send it into darkness and you hope for the best. It's like trying to drive a car while blindfolded in a foreign country on roads you've never seen, with no GPS and no one to ask for directions. That's why NASA never went there, why the Soviet Union never went there, why every space agency on Earth looked at the far side and said, no thank you, too risky, too hard, too expensive. But China innovated. They launched a satellite called KREEP, which means Magpie Bridge in Chinese, a reference to a beautiful folk tale about star-crossed lovers who can only meet once a year when magpies form a bridge across the Milky Way. Poetic, isn't it? They parked this satellite in a special gravitational pocket beyond the moon, a place called a halo orbit where the gravitational forces balance out and the satellite can hover relatively stationary. And KREEP became a mirror, a relay station bouncing signals over the moon's shoulder. Suddenly, the impossible became possible. With this bridge in place, they launched Chang'e 6. That's the Chinese lunar exploration program, named after the goddess of the moon in Chinese mythology. And on June 2nd, 2024, it touched down in a place called the South Pole Aitken Basin. Now, if you're not familiar with this name, let me paint you a picture. The South Pole Aitken Basin is the largest impact crater in the entire solar system. Largest. Not just on the moon in the solar system. It's 1,500 miles wide. That's roughly the distance from London to Rome. And it's 5 miles deep. 5 miles straight down through lunar crust and into the moon's interior. This crater is so old, so ancient, that it formed when the solar system was still in its infancy. An asteroid or comet or rogue planet smashed into the moon with such force that it nearly split the entire world in half, nearly broke it like an egg. The energy released would have melted rock for hundreds of miles in every direction, vaporized entire mountain ranges, reshaped the moon's interior structure. It was one of the most violent events in lunar history. And the scar never healed. The descent was terrifying. For 15 minutes, Chang'e 6 was completely autonomous. AI-guided cameras scanned the surface, identifying safe landing spots, avoiding boulders the size of houses, dodging smaller craters within the larger crater. There was no human hand on the joystick, no real-time control, just pre-programmed algorithms and the hope that they'd work. And they did. The lander touched down gently, deployed its robotic arm, and began drilling into the lunar soil. It scooped up rocks. It grabbed dust. It sealed everything in a container designed to keep it pristine, untouched by Earth's atmosphere. And 53 days later, a capsule landed in Inner Mongolia with 4 pounds of treasure inside. 4 pounds doesn't sound like much, does it? But these weren't just any rocks. These were rocks from a place no human had ever touched, from a crater so deep it had punched through the moon's skin and exposed its interior. These were rocks that could tell us not just about the far side, but about the moon's formation, its evolution, its hidden chemistry. And when scientists opened that capsule and began their analysis, the first thing they noticed was the color. You see, if you look at the moon tonight, and I encourage you to do so, you'll see dark patches scattered across its surface. We call them Maria, those Latin seas, and they give the moon its characteristic man in the moon appearance. Some cultures see a rabbit, others see a woman's face. But whatever you see, you're looking at ancient lava flows. Billions of years ago, the near side of the moon was geologically active. Volcanoes erupted, magma welled up from the interior, and lava flooded vast lowland basins, cooling into black basalt rock. These dark seas cover about 30% of the near side. They're the most recognizable feature of the moon we know. But the far side? Almost no dark patches. Almost none. The far side is white, rugged, heavily cratered, ancient. It looks like a completely different moon. And for decades, this has been one of the great mysteries of lunar science. It even has a name, the lunar dichotomy. Why did one side melt and flood with lava while the other stayed solid and frozen? Why are they so different? The Chang'e 6 samples just gave us the answer, and it has to do with something called KREEP. That's not a spelling mistake, it's an acronym. K for potassium, Re for rare earth elements, and P for phosphorus. This chemical cocktail is radioactive. It produces heat. Not a little bit of heat, significant, sustained geological heat. It's like a planetary electric blanket buried beneath the surface, keeping the rocks warm for billions of years. Now, the Apollo samples from the near side, all those rocks brought back by American astronauts in the late 60s and early 70s, they were full of KREEP, packed with it. The near side was hot. But Chang'e 6 samples? Clean. Almost no KREEP whatsoever. The far side is chemically different. It doesn't have that radioactive heater. And this confirms something scientists have long suspected but couldn't prove. The moon is lopsided on the inside. Let me take you back 4.5 billion years. The moon is newborn, fresh from a catastrophic collision between Earth and a Mars-sized planet we call Theia. The debris from that impact coalesced into a ball of molten rock entirely liquid, a floating ocean of magma with no solid surface whatsoever. As this magma ocean cooled over millions of years, crystals began to form. Heavy crystals, like iron and magnesium-rich minerals, sank toward the core. Light crystals, like anorthite and KREEP-rich materials, floated to the surface like scum on a pond. But here's where it gets weird. For reasons we still don't fully understand, possibly the Earth's gravitational influence, possibly random chance, the KREEP didn't spread evenly. It concentrated on one hemisphere, the near side. And that radioactive blanket kept the near side warm. It thinned the crust by cooking it from below. It made the crust brittle, weak, fractured. And when asteroid impacts struck the near side, they broke through that thinned crust and allowed magma from deep below to well up and flood the impact basins. That's why we see those dark seas. They're volcanic eruptions triggered by impacts, sustained by radioactive heat, flooding the lowlands for billions of years. The far side never had that advantage or that curse, depending on how you look at it. Without KREEP, the far side cooled faster, froze earlier, developed a crust maybe 20 miles thick in some places. When asteroids struck the far side, they couldn't punch through. The impact scarred the surface, created craters on top of craters, but no lava welled up to erase them. The far side became a time capsule, preserving the moon's ancient history in a way the near side never could. The near side was resurfaced over and over again by volcanic activity. The far side stayed intact. So the moon isn't one world, it's two worlds, back to back, with two completely different geological fates. One side cooked itself for billions of years. The other froze solid early and stayed that way. And we had no idea because we could only see one face. We assumed symmetry, we assumed balance, we assumed that what we could see represented the whole truth. And that assumption, that comfortable, reassuring assumption, was wrong. Now, here's where the story gets even stranger. The Chang'e 6 team didn't just find boring old rocks. They found something extraordinary, something that shouldn't exist in nature, something we thought could only be made in high-tech laboratories with lasers and carefully controlled chemical processes. They found graphene. You might have heard of graphene. It's one of those wonder materials that scientists get very excited about. Imagine taking a pencil. The graphite core is made of layers of carbon atoms stacked like sheets of paper. Now imagine peeling off a single sheet, one atom thick. That's graphene. It's essentially a two-dimensional material, a sheet of carbon atoms arranged in a perfect hexagonal lattice, like a honeycomb made of atoms. And it has extraordinary properties. It's about 200 times stronger than steel by weight. It conducts electricity better than copper. It's transparent, it's flexible. It's one of the most remarkable materials ever discovered. On Earth, we make graphene in clean rooms using techniques like chemical vapor deposition or mechanical exfoliation, fancy words for very precise, very expensive processes. It doesn't just happen. You don't find graphene lying around in nature. Or so we thought. Chinese scientists examined the Chang'e 6 lunar soil under electron microscopes, instruments so powerful they can see individual atoms, and found it. Natural graphene flakes, just 2 to 7 atomic layers thick, scattered throughout the moon dust. Not a lot, but it's there, definitively there. And the question immediately became, how? The leading theory is violent, beautifully, brutally violent. You see, The moon has no atmosphere, nothing to slow down incoming objects. When a meteorite strikes the lunar surface, it's traveling at tens of thousands of miles per hour. The impact creates pressures in the millions of pounds per square inch and temperatures that would vaporize steel. For a split second, literally a fraction of a second, the impact zone becomes a forge of unimaginable intensity. And in that forge, carbon molecules are compressed so quickly, so forcefully, that they fuse into perfect hexagonal sheets. Graphene. The moon is a factory, an asteroid impact factory, hammering carbon into supermaterials one collision at a time, and it's been doing this for 4 billion years. Every crater you see on the moon represents a potential graphene formation event. The moon is covered in over 300,000 craters larger than a kilometer across, each one a tiny forge, each one potentially creating wonder materials in its moment of violence. Why does this matter? Because if we're going to build a moon base, and both China and the United States are planning exactly that, we don't have to ship all our materials from Earth. Shipping things to the moon is phenomenally expensive. Every kilogram costs thousands of dollars. But if we can harvest materials on site, if we can mine the lunar soil and extract graphene and other useful substances, we can build habitats, solar panels, electronics, all from local resources. The moon isn't just a destination, it's a quarry, a mine, a source of materials we desperately need. But the discoveries don't stop there, not even close. Chang'e 6 confirms something that fundamentally changes our understanding of lunar history, the global magma ocean theory. For decades, this was just a model, a hypothesis. We thought that when the moon formed from the debris of that ancient collision, it was so hot that it was entirely molten, a ball of liquid rock floating in space, slowly cooling over millions of years. As it cooled, different minerals crystallized at different temperatures. Dense minerals sank, light minerals floated. This process, called differentiation, created the layered structure we see today: a small iron core, a thick rocky mantle, and a relatively thin crust on top. But until Chang'e 6, this was just theory. We had models, simulations, educated guesses. Now we have proof. The rocks from the South Pole Aitken Basin contain a mineral called anorthite, a calcium-rich crystal that can only form by floating to the top of a magma ocean. Its presence in these samples confirms that the entire moon was once liquid, entirely liquid. Picture that for a moment. A world with no solid ground, just molten rock, glowing red-hot in the darkness of space, slowly cooling, slowly forming a skin like cooling soup. The moon isn't a captured asteroid. It isn't a random piece of space debris that wandered into Earth's gravitational embrace. It's our child, born from Earth's flesh in a collision so violent it melted both worlds. The moon is made of Earth's material, reformed in fire, cooled in the void. It's us, transformed. And now, we're going back to visit. But here's what really makes the South Pole Aitken Basin special. That 5-mile depth isn't just impressive, it's revelatory. It punched through the entire lunar crust and exposed the mantle, the deep, rocky layer beneath. On Earth, we've never managed this. The deepest hole ever drilled, the Kola Super Deep borehole in Russia, goes down about 7.5 miles. And Earth's crust is thicker than the moon's. We've never touched the mantle. We've never seen what's beneath our feet. But on the moon, a cosmic accident did the work for us. That ancient impact excavated the moon's interior and spread mantle material across the crater floor. The Chang'e 6 samples contain minerals like pyroxene and olivine, heavy greenish crystals that normally reside deep underground. Finding them on the surface is extraordinary. It's like finding pieces of Earth's liver lying on a beach. It tells us what's inside without having to cut the moon open. And what it tells us is this: the moon's interior is richer in certain elements than we expected. The mantle contains more iron and magnesium than the crust, which makes sense. These are heavy elements that sank during differentiation. But it also contains trace amounts of water-bearing minerals, water deep inside the moon. Not a lot, but it's there. The moon isn't as dry as we thought. It's been hiding moisture in its interior, locked in crystal structures for billions of years. Now, let's talk about water more directly, because this is where the story becomes truly revolutionary. For decades, generations, we were taught that the moon is bone dry, completely, utterly, absolutely dry. The Apollo astronauts confirmed this. The samples they brought back were drier than the driest desert on Earth. There was no water ice, no underground lakes, nothing. The moon was a desiccated corpse, baked by solar radiation for billions of years. Any water that might have existed when the moon formed would have boiled away into space almost immediately. But China's missions, both Chang'e 5 and Chang'e 6, have shattered that belief. In the soil samples, they found something called Ulm-1, a hydrated mineral. That means it's a crystal with water molecules chemically bound inside its structure. Not ice, not liquid water, but H2O nonetheless, trapped in rock, sitting in full sunlight on the lunar surface. And there could be massive amounts of it. Some estimates suggest there might be 270 billion tons of water locked in lunar minerals globally. Billion with a B. Where did it come from? Meteorites. The samples contain fragments of carbonaceous chondrites, rare types of asteroids that are rich in water and organic compounds. These are the building blocks of the solar system, primitive materials left over from when the sun and planets formed. They're essentially frozen time capsules from the dawn of creation, and they've been raining down on the moon for 4 billion years. With no atmosphere to burn them up, no rain or wind to wash them away, they just accumulate. They mix into the soil, they become part of the lunar landscape. But it gets even better. Remember those glass beads I mentioned? When meteorites strike the moon, the impact heat is so intense that rock melts instantly. Droplets of molten stone are flung into the lunar sky, cool in mid-flight, and fall back to the surface as tiny glass spheres. The lunar soil is absolutely full of them. Billions and billions of microscopic glass beads, invisible to the naked eye, but abundant under a microscope. Chinese scientists examined these beads closely, and inside, water. Not a lot per bead, just a few parts per million. But there are so many beads, covering such a vast area, that the total adds up quickly. One estimate suggests these glass beads alone could hold enough water to fill a lake the size of Lake Tahoe, and it's incredibly easy to extract. You just heat the beads, the water evaporates out. You collect the vapor, condense it, and you've got drinkable water. The mechanism is elegant. The solar wind, a constant stream of charged particles flowing out from the sun, carries hydrogen atoms. These hydrogen atoms strike the lunar surface and penetrate into the glass beads. Inside the beads, the hydrogen encounters oxygen atoms in the silicate structure. H plus O becomes H2O, water. The beads act as tiny factories, making water from solar wind and storing it for us. The moon has been producing water quietly and continuously for billions of years. We just didn't know. This changes everything. If water is everywhere on the moon, not just in permanently shadowed craters at the poles, but mixed into the soil across the entire surface, then we can get water anywhere we land. We don't need to set up shop in one specific location. We just need a shovel and an oven. Metaphorically speaking, this dramatically expands where we can build lunar bases, how we can sustain human presence, what we can achieve. But water isn't the only valuable resource China found. They also discovered something that could revolutionize energy production on Earth. In the samples, they identified a new mineral they named Chang'e. Why? It's a columnar crystal, transparent, beautiful under a microscope. And inside this crystal, helium-3. Now, unless you're a nuclear physicist, helium-3 probably doesn't mean much to you. Let me explain why it matters. Helium-3 is an isotope, a variation of regular helium with one less neutron. It's extraordinarily rare on Earth. Our planet's magnetic field deflects most of it. But it's the holy grail of fusion energy. If we can get nuclear fusion to work commercially, and that's still a big if, but we're getting closer, helium-3 would be the perfect fuel. It produces energy without creating radioactive waste. It's clean, it's efficient, it's safe compared to other fusion reactions. Earth has almost none. The moon has been soaking it up from the solar wind for 4 billion years. It's embedded in the top few meters of lunar soil. Estimates suggest there's roughly 1 million tons of helium-3 on the moon. And 100 tons could theoretically power the entire Earth for a year. 100 tons. The moon has enough to power human civilization for thousands of years. China has explicitly stated publicly, openly, that they're interested in mining the moon. They're not shy about it. They see the moon not just as a scientific curiosity, but as a resource base, a strategic asset. And if they can develop the technology to extract and transport helium-3, the moon becomes the Persian Gulf of the 21st century, the most valuable real estate in the solar system. Now, I want to circle back to something that ties all of this together. The Apollo samples told us the moon's volcanoes died about 3 billion years ago. The near side cooled, solidified, became geologically dead. But Chang'e 5 samples from a different location on the near side, dated to only 2 billion years old. The moon stayed active 1 billion years longer than we thought. How? Why? The answer is that radioactive creep. It kept parts of the near side warm enough for volcanic activity to continue, but it wasn't uniform. Some regions cooled faster than others. The moon died unevenly, in patches, over a span of 1 billion years. And the Chang'e 6 samples from the far side tell the other half of the story. They're older about 2.8 billion years. The far side, without that radioactive blanket, froze solid earlier and stayed that way. For 1 billion years, the moon was split. One hemisphere still erupting with lava, still geologically alive, still producing those dark basalt seas. The other hemisphere, cold, silent, inactive, preserving ancient craters like a museum. The moon wasn't uniformly dead. It was dying slowly, from one side to the other, clinging to life as long as its radioactive fuel lasted. This is the lunar dichotomy in full. Not just surface features, but chemistry, timeline, fate, 2 worlds sharing one body. So what do we do with all this knowledge? What does it mean for us, practically speaking? China isn't just publishing papers, they're building infrastructure. They've announced the International Lunar Research Station, the ILRS. They plan to establish a permanent base at the South Pole by the 2032. They're inviting other nations to join. Russia has signed on, others are considering it. The goal is to create a sustainable human presence on the moon, not a few days, not a flag-planting mission, a permanent station where astronauts live and work for months at a time. And they've chosen the South Pole for good reason. Shackleton Crater sits there, a 40-mile wide impact crater with ridges that receive near-constant sunlight for solar power and deep shadows that hold water ice. It's prime real estate, an oasis in a desert, and both China and the United States are targeting it. NASA has identified 13 potential landing sites for the Artemis program, and most of them cluster around the same craters China is eyeing. We're heading for what some are calling a celestial traffic jam. Unlike the 1,960-second space race, where the goal was to get there first, plant a flag, and declare victory, this time we're building infrastructure, permanent structures, resource extraction facilities. This time, we're staying. And there are only a few good locations. The South Pole is the most obvious choice, but there's limited room. What happens when 2 nations want the same crater rim? The discovery of water distributed across the lunar surface might ease some of this pressure. If we can extract water anywhere, maybe Shackleton isn't the only option. Maybe we can build bases in multiple locations, reducing competition, spreading out human presence. But the resources are still concentrated. The helium-3 is in the soil everywhere, but extraction will require significant infrastructure. The graphene forms in impact zones, which are everywhere, but not uniformly. Whoever establishes the first permanent base gains a strategic advantage. Now, I want to bring this back to you, back to your life, your understanding, your perspective, because the moon is teaching us something important, something that applies far beyond lunar geology. It's teaching us about the danger of assumptions, about the blindness that comes with familiarity, about the importance of looking at what we've stopped noticing. Think about the things in your life you believe you understand completely. Your home, your routine, your relationships, your own mind. We tell ourselves we know these things. We've lived with them for years, maybe decades. We've named them, categorized them, assigned them meaning and value. And in that process of familiarization, we often stop investigating. We stop asking questions. We assume we've seen everything there is to see. But the moon teaches us that familiarity is not the same as understanding. Just because you see something every day doesn't mean you truly know it. Just because you've looked at something 1,000 times doesn't mean you've seen all of it. There's always another side, always another layer, always something hidden in the shadows, waiting for the right light, the right angle, the right question. The near side of the moon lulled us into complacency. We assumed it represented the whole truth. We didn't account for the far side being fundamentally different. And I wonder how often we do this in our own lives. How often do we assume that what we can see is all there is? How often do we mistake the visible for the complete? Think about a person you believe you know well, a partner, a parent, a close friend. You've spent countless hours together. You've shared experiences, conversations, moments of intimacy and vulnerability. And yet, there's always a far side, isn't there? Parts of them you haven't seen, experiences you haven't shared, thoughts they've never spoken aloud. We're all like the moon showing one face to the world, while keeping another hidden, not from malice, but simply because that's how complexity works. We're not symmetrical creatures. We're lopsided, multifaceted, full of contradictions. Or think about your own mind. You live inside it every day. You think you know how it works, what it values, what it fears. But there are depths you haven't explored. There's a far side to your own consciousness, unconscious patterns, unexamined assumptions, beliefs you inherited without question. And until you turn your attention there, until you actively investigate the parts of yourself you take for granted, you're only seeing half the picture. The moon spent 4 billion years keeping secrets. Not because it was trying to deceive anyone, but because we never thought to look. We stopped being curious the moment we felt we understood it. And that's the real lesson here. Curiosity isn't just about novelty. It's not just about exploring new things. It's about staying curious, about the familiar, about questioning the things you think you already know, about looking behind the mask, especially when you've seen the front of the mask 1,000 times. So here's a practice for you. A simple one, but profound if you take it seriously. Look at something in your life you believe you understand completely. It could be a place, your home, your neighborhood, a route you drive every day. It could be a person, someone you've known for years. It could be a habit, a belief, a story you tell about yourself. And ask, what's on the far side? What haven't I investigated? What have I assumed without checking? Maybe you've lived in your home for 10 years and you've never looked in the attic. Maybe there's a conversation you've never had with your partner because you assumed you knew how they'd respond. Maybe there's a career path you never explored because you told yourself a story about who you are and what you're capable of. These are your unexplored far sides. These are the places where the radioactive elements might be concentrating, where the chemistry might be different, where the history might be more complex than you thought. And here's the thing about scars. The South Pole Aitken Basin is a wound, a catastrophic injury that nearly destroyed the moon. But that wound became a window. It exposed the interior. It revealed what couldn't be seen otherwise. The violence that created it also created the opportunity for understanding. I wonder if the same is true in our lives. The difficult experiences, the painful moments, the times we felt broken or damaged, maybe those aren't just scars. Maybe they're windows. Maybe they're places where the surface has been punctured and the interior is visible. If we're willing to look, not to dwell in pain, but to understand ourselves more deeply, to see what's beneath the familiar surface. The moon also teaches us about asymmetry. It's not balanced, it's not symmetrical. One side is radioactive and volcanic, the other is cold and ancient. And both sides are real. Both sides matter. Both sides are part of the whole truth. You're the same way. You're not a simple, consistent, symmetrical person. You have a side that's active, visible, expressive, the face you show to the world. And you have a side that's quieter, more private, more complex, the face you keep hidden. One side might be warm and welcoming. The other might be guarded and self-protective. One side might be confident and capable. The other might be insecure and uncertain. And all of this is okay. It's not a flaw. It's not something to fix. It's just the nature of being complex. The mistake is judging yourself by only one hemisphere. The mistake is thinking that because you show one face to the world, that's who you really are. Or thinking that because you keep one side hidden, it's somehow less valid, less real, less worthy of attention. Both sides are you. Both sides have formed through your unique history, your unique chemistry, your unique experiences of heat and cold, activity and dormancy. And here's something else the moon teaches us. What looks dead might just be dormant. The moon isn't dead. It's quiet, it's paused, but it's still there, still holding resources, still containing potential. The volcanoes aren't erupting anymore, but the energy isn't gone. It's stored in different forms, in minerals, in water, in helium-3. How many things in your life have you written off as dead, finished, over? How many relationships, dreams, talents, possibilities have you closed the book on because they went quiet? Maybe they're not dead. Maybe they're just dormant. Maybe they're waiting for the right conditions, the right question, the right moment to activate again. The moon waited 50 years for us to ask new questions. And when we finally did, it revealed itself to be far more interesting, far more valuable, far more alive with potential than we ever imagined. What's been waiting in your life for you to ask a new question? What's been dormant, patient, ready to surprise you if you just turned your attention back to it? Now, I'm not suggesting you need to mine your life for resources in a cold, transactional way. That's not the point. The point is recognizing that nothing is as simple as it first appears. That depth exists even in the familiar. That complexity is everywhere if you're willing to look for it. That the things we dismiss as boring, understood, or exhausted are often the things with the most left to teach us. China went back to the moon because they refused to accept that it was solved. They refused to believe that the Apollo missions had extracted all the knowledge worth extracting. They asked, what if we've only seen half the story? And that question led to extraordinary discoveries. Graphene, water, helium-3, asymmetric chemistry, extended volcanic activity, a global magma ocean, mantle minerals. Every single one of these discoveries was hiding in plain sight, waiting for someone to look in the right place, with the right tools and the right questions. So, what are you not looking at? What have you decided is too familiar to investigate? What have you assumed is simple when it might actually be complex? What have you dismissed as dead when it might be dormant? These aren't abstract questions. They have real answers. And those answers might change your life, not in a dramatic Hollywood way, but in a quieter, deeper way. The way understanding changes things. The way curiosity opens doors. The way looking at the far side reveals a completely different world than you expected. The moon is lopsided, so are you. And that's not a problem. That's not something to fix or hide or be ashamed of. It's just the truth of being complex, of having history, of having been shaped by different forces in different ways over time. The near side of you, the part you show to others, has been bombarded by different things than the far side, the part you keep private. And both sides are valid, both sides are real, both sides are part of who you are. So here's what I want you to take away from all this. Here's the truth I hope settles into your bones and changes how you see things. You are not finished. You are not solved. You are not simple or predictable or completely understood, not by others and not even by yourself. There is always a far side, always a hidden chemistry, always a depth you haven't fully explored. And that's okay. In fact, that's wonderful, because it means you're still full of possibility, still capable of surprising yourself, still worth investigating. The moon kept its secrets for 4 billion years. And the moment we stopped assuming we knew it, The moment we got curious again, it revealed itself to be extraordinary. You're the same way. You're full of resources you haven't tapped, full of materials you haven't extracted, full of stories you haven't told. And you don't need to go to the moon to find them. You just need to turn your attention to what you've stopped noticing, to the familiar things you've taken for granted, to the side of yourself you've been hiding, even from yourself. The moon is two worlds pretending to be one, and so are you. One side visible, familiar, documented. The other side hidden, complex, waiting to be explored. And both sides matter. Both sides have value. Both sides are part of the whole truth. So, stay curious. Keep asking questions. Keep looking at the far side of things, especially when you think you already know the answer. Because the things we think we understand best are often the things we understand least. And the moment we stop being curious, we stop discovering, we stop growing, we stop seeing the extraordinary in the ordinary. The moon is lying to us, not maliciously, but by omission. It shows us one face and we assume that's the whole story. But there's always another side, always another layer, always something hidden in the dark, waiting for the right light, the right angle, the right question. You're not broken, you're not simple, you're not solved. You're complex, asymmetrical, full of contradictions and depth and hidden resources. You're lopsided, like the moon. And that's exactly as it should be. So here's your mantra, the thing I want you to remember. You are not finished, you are not solved, there is always another side. Now, if this landed for you, if it shifted something in how you see the moon, or yourself, or the things you take for granted, I'd love to hear about it. Leave a comment below. Tell me what you're going to look at with fresh eyes. Tell me what far side you're ready to explore. And if this resonated, if it gave you something valuable, hit that like button. It helps more people find this message. And subscribe, because we're just getting started. There are more mysteries hiding in plain sight, and I want to explore them with you. Keep looking up, keep asking questions, keep being curious about the familiar. And remember, the things you think you know best are often the ones with the most left to teach you. Thank you for spending this time with me. Thank you for being curious. Thank you for being willing to look at the far side. I'll see you in the next one.